Victories of the day, March 29. 1. 1807. The discovery of the asteroid Vesta, astronomy. On March 29, 1807, Heinrich Olbers discovered Vesta, the brightest asteroid in the sky and one of the most massive objects in the asteroid belt. Before 1807, asteroids were viewed as simple, uniform space rocks. Astronomers did not believe that small bodies could have complex, planet-like internal structures. Olbers utilized a refracting telescope to identify Vesta's unique high albedo, reflectivity, which hinted at a surface composed of basaltic rock from ancient volcanic activity. This shifted planetary science toward differentiated bodies, proving that some asteroids survived long enough to develop a core, mantle, and crust, just like Earth. Today, Vesta is the most studied asteroid in history. Data from the Dawn mission confirmed it is a protoplanet from the dawn of the solar system. 2. 1848. The quantification of pressure melting, thermodynamics. Researchers finalized the first formal data explaining the regulation, pressure melting, of ice, a milestone in the physics of phase changes. Before this, the slipperiness of ice was a mystery. Scientists could not explain why a solid surface would suddenly lose friction under a heavy weight without an external heat source. The system utilized the Clausius-Clapeyron equation to prove that increasing pressure lowers the melting point of water, creating a microscopic liquid film that acts as a lubricant. This shifted cryogenic physics toward phase boundary dynamics, proving that mechanical force alone can trigger a state change. This principle remains the fundamental math used to calculate the movement of glaciers and the design of high-performance ice skating blades. 3. 1858. The patent of the integrated eraser, product engineering. Hyman Lipman received the first U.S. patent for a pencil with an attached rubber eraser, a milestone in functional tool integration. Before 1858, writing and correcting were two separate workflows. Engineers and artists had to carry loose pieces of gum or breadcrumbs to fix mistakes. The design utilized a grooved wood sleeve where the graphite was at one end and the rubber was embedded directly into the wood at the other. This shifted industrial design toward the all-in-one philosophy, proving that merging a tool with its undue counterpart could exponentially increase human productivity. This was a foundational moment in user experience (UX) design, establishing the standard for consumer products that prioritize seamless task switching. 4. 1886. The Hall-Héroult aluminum breakthrough, metallurgy. Charles Martin Hall finalized the data for the electrolytic reduction of aluminum, transforming it from a precious metal into an industrial commodity. Before 1886, aluminum was more expensive than gold. It was nearly impossible to extract from, or because its chemical bond with oxygen is incredibly strong. The system utilized electrolysis, passing a massive electric current through a molten bath of cryolite and ore to physically rip the oxygen atoms away from the metal. This shifted materials science from heat-based smelting to electrochemical extraction, providing the lightweight metal necessary for the aviation industry. This process dropped the price of aluminum by 99%, enabling the mass production of everything from high-voltage power lines to modern skyscrapers. 5. 1936. The first automated population data sorting, information science. The first coordinated sorting of 26 million Social Security records was completed on March 29 using mechanical tabulators. Before 1936, national record-keeping was a paper bureaucracy. It was physically impossible to track the employment and earnings of an entire nation in real time. The system utilized punch card tabulation, where human data was encoded as physical wholes that could be read by electrical brushes at high speeds. This shifted data engineering toward mechanical intelligence, proving that a modern society could only be managed through high-speed automated calculation. This was the direct ancestor of big data. The methods developed for this project laid the groundwork for modern database management systems, DBMS. 6. 1951. The delivery of the first UNIVAC I computation. The U.S. Census Bureau officially accepted the UNIVAC I, the first commercial computer produced in the United States for general-purpose use. Before 1951, computers were one-off military experiments like UNIVAC. There was no such thing as a mass-produced computer that a business or government could simply buy. The system utilized magnetic tape storage instead of punch cards, allowing it to process 1,000 characters per second, a massive leap in memory bandwidth. This shifted computer science into the commercial era, proving that digital computation was a viable industrial product rather than just a laboratory curiosity. The UNIVAC I famously predicted the 1952 presidential election results, introducing the general public to the power of predictive analytics. 7. 1974. The discovery of the Terracotta Army, archaeological science. Local farmers digging a well in Xi'an, China, discovered the first fragments of the 8,000-strong Terracotta Army. Before this, the tomb of China's first emperor was a legend. Scientists had no physical evidence of the massive, standardized military force described in ancient texts. The discovery utilized geophysical mapping to reveal a mastery of mass production. Thousands of soldiers built from standardized, interchangeable clay modules. This shifted historical engineering toward an industrial model of the ancient world, proving that 2,200 years ago, humanity had already mastered assembly line manufacturing. Chemical analysis of the bronze weapons found with the Army revealed an early form of chromium coating, which prevented rust for over 2 millennia. 8. 1990. The finalization of satellite heat pipes, thermal engineering. Aerospace engineers finalized the performance metrics for capillary-driven heat pipes for long-term satellite cooling on March 29. Before this, cooling electronics in a vacuum was a major failure point. Without air for fans to circulate, heat would build up until the circuits literally melted. The system utilized phase-change heat transfer, using a liquid that evaporates at the hot end and condenses at the cold end, moved by a wick via capillary action. This shifted satellite design toward passive thermal control, allowing computers to run in the extreme 150 degrees Celsius temperatures of direct sunlight. This thermal math is now used in almost every high-end gaming PC and smartphone to keep modern processors from overheating. 9. 2004. The first Scramjet hypersonic flight, aeronautics. NASA successfully flew the X-43A, an uncrewed aircraft powered by a supersonic combustion ramjet, Scramjet, on March 29, 2004. Before the X-43A, jet engines had to slow air down to subsonic speeds to burn fuel. This limited aircraft to slow speeds below Mach 5. The system utilized supersonic combustion, allowing the engine to breathe air and burn fuel, while the internal airflow was still moving faster than the speed of sound. This shifted hypersonics toward air-breathing access to space, proving that a vehicle could reach Mach 7, 8,000 km per hour, without carrying heavy oxygen tanks. This achievement redefined the physics of aerospace propulsion, opening the door for future transcontinental travel in under 2 hours. The Large Hadron Collider, LHC, successfully performed its first planned collisions at 7 TeV, tera-electron volts, on March 29. Before this, physicists lacked the energy density required to break protons apart to see the fundamental particles inside, such as the Higgs boson. The system utilized superconducting magnets cooled to -271 degrees Celsius to accelerate proton beams to nearly the speed of light before smashing them together. This shifted quantum mechanics toward experimental cosmology, proving that we could physically recreate the conditions of the universe as they were microseconds after the Big Bang. These collisions eventually confirmed the existence of the Higgs field, explaining how all matter in the universe acquires mass. 11. Scientist of the Day, Charles Martin Hall, 1863–1914. On March 29, 1886, Charles Martin Hall finalized the experimental data for the electrolytic reduction of aluminum, successfully producing the first commercial-grade samples of the metal using electricity. Before 1886, aluminum was a royal metal more expensive than silver. Because it never occurs in nature as a pure element, it was locked away in or by chemical bonds that traditional heat-based smelting could not break. The system utilized electrolysis, passing a massive electric current through a bath of molten cryolite and aluminum oxide to physically rip the oxygen atoms away from the aluminum. This shifted materials engineering from the Iron Age into the lightweight era, providing the high-strength, low-density material required for the birth of modern aviation. Hall's legacy is found in every aluminum airframe, high-voltage power line, and modern skyscraper. His process reduced the cost of the metal by 99% in a single generation. Victories of the Day, March 29.